Hello friends, today we have with us a very special guest who will teach us about the volume and capacity of cuboid and cylinder. So give a big round of applause to Mr. Joker.
So serious.
Let's start with one-dimensional shape. What is one-dimensional shape? I'm telling you to draw lines of 10 centimeter. Few children will draw a thin line of 10 centimeter length. Few will draw a little thicker. Others can draw with a sketch pen and it will be quite thick. Which one is correct? What do you think? Yes, all of them are correct. That means to find length, perimeter, diameter, radius, etc., we consider only length and thickness does not matter. That means we are considering just one dimension. Okay, suppose we add one more dimension, then what do we measure? We measure areas. So many things are there, 2D, 3D. Solid figures are also there, but we measure their area in two dimensions only. You can see these figures. To find the area, surface area and other flat surfaces, we consider only two dimensions. That means height and thickness, etc. And length. The third dimension we don't measure. Okay. So for this cuboid, length is there and breadth is there. We will measure length, breadth. It is written here depth. You can give any name to anything, and height doesn't matter. Whether the height is less or it's a short or a tall one, but area would be same. So this cube also, area is same whether the height is different. For this boy, only the leg space, only the feet space covered by the feet is the area. And for this girl also, only the shoe coverage. What about this boy? Only the palm, area of the palm. Okay, let's add one more dimension to it. You can see very clearly that the net is a two-dimensional shape and which is changing into three-dimensional just by folding. When we are considering the thickness, we are taking it into three dimension. It is, when it is in the shape of a net, it is only length and breadth. But when it is converted into a cube, we are taking length, breadth and height. So to find the volume, capacity, etc., we consider length, breadth and also height. You can call it depth also. Where are the three dimensions lie? They are all at 90 degrees to each other. Let's find out the next. What is volume? Any idea? What is volume? What do you mean by volume? Yes, volume refers to the amount of space occupied by an object. Then what is capacity? Capacity refers to the quantity that a container holds. Is it the same thing or they are different? Because when we talk about the volume, we talk about the capacity also, because capacity can be calculated by the volume only. If there is a glass, whatever volume it occupies, the space it occupies, it can hold the same amount in it. So it is equal to the capacity also. But then why we have given them two terms, two different names? Because they are not exactly the same. Suppose there is a solid wood and it occupies the space, but it cannot hold any liquid or anything inside it. So its capacity is 0. So first take out the volume. You can see the cubes. How can we find the volume of a cube? This is the basic formula. If you have to calculate the volume of any shape, first just multiply, take the base area and multiply it with the height. Whatever the shape of the base is, just multiply it with the height and you will get the volume. So, for the cube, it is the length, it is breadth, and it is height. But you know that the cube has all the three equals. So, we can call it side. So, let's see what the formula is. Side into side gives the area, and if we multiply one more side, it gives the volume. So, the final formula comes side cube. Next, which shape is this? It's a cuboid. Cuboid has different length, breadth, and height. So, you know the basic formula to find out the volume of a cuboid. The basic formula is again the same, base area into height. And how will you find the base area? Just by multiplying length into breadth. And if you multiply the length into breadth with the height, it gives the volume. So the final formula is length into breadth into height. Let's go to the new shape. Which shape is this? Yes, it's a cylinder. Again, same, volume is equal to base area into height. You can see the base area. The shape of the base is a circle. And circle formula, what is the formula? Yes, correct. It is pi r square. And what is the height? Height is h. So the final formula will be pi r square h. Wonderful. Let's see the units. Before going to the capacity, let's see the units. What are the units we measure in? These things. So for the length, we take the single unit. It could be millimeter, meter, centimeter, kilometer, etc. You measure the length, it is the distance is 1 kilometer. The length of the table is in meter. And likewise, when we measure the area, we take two dimensions. So it becomes millimeter square, meter square, centimeter square, kilometer, etc. And when you have to convert 1 kilometer square, you will convert it into 1 kilometer into 1 kilometer. And each one will be converted into meter and the final answer will come. Likewise, if we are considering the volume, we will take three dimensions. So millimeter cube, meter cube, centimeter cube, kilometer cube, etc. And when we have to convert, we'll convert all the 3 kilometers into meter and then the final answer will come. Whether we are converting meter to centimeter, meter cube to centimeter cube, kilometer cube to any other unit, we will follow the same rule. Oh, what is this? Liquid. How can we measure the capacity? What are these? Have you ever seen these things? Yes, these are measuring cylinder you must have seen in the kitchen or in the laboratory. People measure the liquids. Even the ladies measure the liquids for making the different dishes with this measuring cylinder. You can see the units. It's 50 milliliter, 100 milliliter, 250 milliliter, 500 milliliter, and 1000 milliliter. So it's not centimeter, meter. It is a different unit. We measure liquid in milliliters and liter. So what is the relation between centimeter and liter? Let's see this also. You all can visualize 1 centimeter. Just because you are using ruler in everyday life, 1 centimeter is so small. So just imagine a small cube whose length is 1 centimeter, breadth is 1 centimeter, and the height is also 1 centimeter. So this is volume is 1 centimeter cube. From which unit you are using the liter, milliliter in everyday life? So 1 centimeter cube is equal to how much liquid? Yes, your guess is correct. It is equal to 1 milliliter. Let's relate 1 liter also. For that, you imagine a little bigger cube with 10 centimeter length, 10 centimeter breadth, and 10 centimeter height. So this cube, the amount which it holds, that is equal to 1 liter. How can you write and how can you relate? 1 liter is equal to 10 centimeter cube, or 1 liter is equal to 1000 centimeter cube. So 10 centimeters inside the bracket, when it comes out, it becomes 1000. And then if you multiply 1 liter with 1000, it becomes 1000 liter. And if you multiply 1000 with 1000, it becomes 1 meter cube. So now I think you have understood how to convert volume into capacity. Can you tell the capacity of this Coca-Cola bottle? Yes, you can guess right. Now let us try our knowledge with some example. Let us apply it. So one question is, water is pouring into a cuboidal reservoir at the rate of 60 liter per minute. If the volume of reservoir is 108 meter cube, find the number of hours it will take to fill the reservoirs. We will read the question 2 times to understand it. So there is a reservoir. It is a cuboidal shape and its capacity is 108 meter cube. So we have to convert it into liter, which we can. Then it is telling that this reservoir is filling and the rate is 60 liter per minute. That means in 1 minute 60 liter water is going inside. And what we have to find out, the number of hours. It is given in minute and we have to find the number of hours it will take to fill the reservoirs. First, yes, rightly said, we'll convert it into liter. So the volume of reservoir is 100 meter cube and 1 meter cube is equal to 1000 liters. So this is equal to 1,08,000 liter. Wonderful. Now we have to find the time. This is very easy. We can divide this capacity with 60 minute. So it will give 1800 minute, which by dividing 60, it gives 30 hours. So easy. Wonderful. Can we try the second question? Another example. Okay, diameter of cylinder A is 7 centimeter and height is 14 centimeter. Diameter of cylinder B is 14 centimeter and height is 7 centimeter. That means there are two cylinders. So cylinder 1 and then cylinder B, cylinder A. First one, diameter is 7 and the height is 14. Another one, it is in the reverse direction. Diameter is 14 and the height is 7. Without going any calculation, can you guess whose volume is greater? Verify it by finding the volume of both the cylinders. Check whether the cylinder with a greater volume has greater surface area also. Wonderful. These are the two cylinders. You can see the measurements are in the reverse direction. So can you guess whether the volume, surface area would be same or different? And if different, which one will have greater? It's your time to guess. Calculate it also. First guess and then calculate. Let's see. What is the formula for the volume of cylinder? Yes, it is pi r square h. And what is the formula for the total surface area of cylinder? Yes, it is 2 pi r h plus 2 pi r square. So, if your guess was that cylinder B is greater in both the things, your guess is correct. Let's see why. We can see that volume and the total surface area both depends upon square of radius. You can see here, this is also equal to square of radius, and here also radius is in the square unit, and unit of height is only singles. Here also you can see that the height is in the single unit, and here also height is single. It's not square or cube. So whose radius is more will have greater surface area and volume. Got it? Let's see the calculation. This is pi r square h. First, we'll find the volume of cylinder A. It is the value of pi. R is, because diameter is 7, so the radius is 7 by 2 multiplied by 7 by 2 and 14 is the height. Volume is 539 centimeter cube. Let's find the volume of cylinder B. It is 1078 centimeter cube. Here, radius is 14 by 2 and the height is 7. Let's find out the total surface area of cylinder A. This is 2 pi r plus h. So when you calculate, you will get it is equal to 385 centimeter square. And what about the total surface area of cylinder B? Just by putting the values, we will get 616 centimeters square. So in both the way, you can see that the volume of cylinder B is greater and the total surface area is also greater. So I'm very clear. If you are given 3 types of glasses, which one will you take if you like that? Okay. I think we can go for the next one more example. It's a cube. What is the question? If each edge of a cube is doubled, the edge means sides, these sides. How many times will its surface area increase and how many times will its volume increase? Give a pause and think over it. Relate it with the formula. Let's check. If the edge of a cube is edge S, then its total surface area is 6s square. When the edge became 2s, so the new total surface area is equal to 6 into square of 2s, which means 6 into 2s is equal to 6 into 4s square. So now you compare the original area and the new area. 6 is same s square and here it is 4s square. Yes, so the relation is 1:4. Will you try for total surface area? This is the total surface area. Will you try for the volume? Okay. Yes. In the same method, when it was side was S, the volume was S cube. When the side was 2S, the new volume became cube of 2S. That means 2S into 2S into 2S, which is equal to 8S cube. Now, just compare S cube and 8S cube. Yes, wonderful. The ratio is 1:8. What is this? So many cubes. Okay. If each edge of a cube is 3 times or 4 times, how many times will its surface area increases and how many times will its volume increases? Now I'm very sure that you will find the value, isn't it? Okay. What is this? A big cube, cuboid, and so many small cubes are getting inside. It's looking very fabulous, fantastic. So the question is, a cuboid is of dimensions 60 centimeter into 54 centimeter into 30 centimeter. How many small cubes with side 6 centimeter can be placed in the given cuboid? So in the bigger one, so many small cubes are fit, and you have to find out the number of cubes which are inside. Yes, we will take out the volume. Let's see how. So number of small cubes to be placed in the cuboid is equal to volume of cuboid divided by volume of cube. So volume is 60 into 54 into 30. We have taken it from here. 60, whatever is given in the first is the length, then breadth, and then height. This is the sequence. Normally it is given. And because it is a cube, all of them are same. 6 into 6 into side. So 60 will divide it by 7 and answer is 10. 54 is divided by 6 and answer is 9. 30 is divided by 6 and the answer is 5. Just multiply these three numbers and you will get 450 cubes. Wonderful. I think now this concept is very, very clear to you. And if you have any doubt, you can write in the comment box. You can like it. You can share it. You can subscribe. Anything, just like leave the comment. Thank you.